Hello everyone, my name is Raul Rocio,
Hi, my name is Miguel Gutierrez.
and today we'll be introducing our final project, which is an ultrasonic parking sensor with a buzzer. Do you wish you could put a parking sensor on your old car, farm equipment, trailer, or anything else you have to fit into a tight spot, and you can't see how close you are to hitting what's in front of you? Well, that's exactly why we created this product, to help the everyday person that needs help but has no one there to help them out with parking or reversing their big equipment.
Description of the product. Introducing our innovative small universal ultrasonic parking sensor. This sensor detects objects within a remarkable range of approximately 1 foot. Additionally, this sensor serves as a reliable safeguard for your vehicle. Once an object is within proximity, it activates a warning buzzer, alerting you to your proximity to the obstacle ahead. So the next couple of slides, we'll be going over the operation of the product, part 1 and part 2, the development and results, part 1, part 2, to give a better understanding of how the ultrasonic sensor works within the schematics, which we'll be demonstrating at the end of the presentation slides.
Operation of our product part one. Our product works by using a Arduino board along with an ultrasonic sensor and a buzzer. Our product works by programming the Arduino board to let the sensor read a foot in front, and then once an object is in that radius, it will send a signal to the buzzer to go off. And then once it gets to half that distance, the buzzer will go off twice as loud. And then half that distance, the buzzer will go off again twice as loud as the second time. If you could see on our far right hand side, you could see a real life view of how we built it on a breadboard. As you can see, we have all the leads going into the Arduino board, and it's being powered by a computer right now on the picture screen, but it will be powered by a 9-volt battery, as explained in part 2.
Operation of the product, part 2. This is the product of the 9-volt battery of the Arduino system, as you can see on your left of this figure. In order for this product to operate properly, it must be coded first, as you saw from the previous slide, for the ultrasonic sensor to activate the buzzer. Therefore, once it is coded, disconnect the USB cable and connect the 9-volt battery with the T-type connector to the barrel jack of the Arduino board. As you can see from the schematics in the middle, the whole system is operated properly due to the 9-volt battery activating the sensor along with the buzzer. To add more context, to your right, we created this real life of how it looks and operated due to the green light turning on the Arduino board and the yellow light activating the ultrasonic sensor when it buzzes.
Okay, for the development for our product, we did run into some issues in the beginning. So like first we did when we were doing our wiring on an Arduino board, as shown in the very far left picture. First we developed the circuit on the board and messed around with how we were going to actually want it. When we did that, it was working perfectly fine and everything, but we only used one wire from the Arduino to the breadboard, which caused us to run into our first mistake when we were trying to mount the Arduino board and the ultrasonic sensor to the toy car, because the wiring was way too short. So we had to splice two wires together, and then heat wrap the two connections so that way it's safe and wrapped around and protective coating, and not just live wires hanging out. And then after that, when after that, our second problem was the shell of the car. When we were able to mount the actual sensor in the Arduino board, the sensor was in the way of the shell going completely down on the car for it to sit right. So I had to take a Dremel and cut out a little section of the shell so that way it could fit the ultrasonic sensor properly. But as soon as I did that, the sensor fit perfectly fine and everything was working perfectly.
Results part 1. We were able to successfully make the sensor read how close you are and give you 3 different sounds depending on how close you want to park. So in this slide, this is a vertical view of how the sensor works with 2 arrows when it detects an object. Within a specific amount of distance, the red arrow is transmitting the waves, meaning it is sending waves to the object, which will reflect the waves to the sensor, which is the green arrow, that would initiate the buzzer to be active in different tones. Results part 2. This is similar to the previous slide, just horizontal view of how it looks when getting close to the object when parking or any object that's detectable. Next, we will demonstrate you in real life of how it is operated.
Okay, so now does anybody have any questions for me or Miguel? We have worked tirelessly on this prototype and on this concept and on this presentation to be able to provide y'all with an example and a full description of our product. So if anybody would have any questions for us at this time, please be feel free to ask. From parking lots to tight urban spaces, we believe our device is able to help all drivers in all situations to be able to be aware of their surroundings and make sure they don't hit nothing or cause damage to somebody else's property, which then causes more problems, and nobody wants that. So, without further ado, thank you guys for your time. Me and Miguel appreciate your patience with our presentation. And if there's no questions, thank you.
As we conclude our presentation in our innovative project, we want to express our gratitude for your time and attention to showcase not just a technological innovation, but a solution aimed at enhancing safety and convenience in parking scenarios. Nevertheless, we welcome any further questions or feedback and look forward to exploring possibilities for refining and implementing our own device for broader applications. Thank you, everyone.